Thank you. I'm going to briefly talk about premature generalization, also known as you aren't going to need it. This is the urge to solve more problems than necessary, just in case, or anticipating future problems and prepare for them in advance, still just in case. So here's perhaps a contrived example. Imagine you want to print hello world, but you want it to be as general as possible in case you need to change anything in the future. So you have your hello world function that takes an output factory and a message factory. You construct the printer of the output factory, and then you construct a message factory, and then you call print on your output factory, and you create a message. And then in your main function, you decide that you want to print to stood out, and you decide you want to print hello world, and then you call your function. So then it's very flexible. You can change the output factor to print to stood there, for instance, or to a file, and so on, or other messages. Or you can just write like this. It's much simpler and faster. The benefit of this, of course, is that it's easier to understand, and it's also really easy to change. If you need to print to stood in the future, it's really easy to make that change here. So it was a little bit wasteful, perhaps. So warning signs that your coworkers might suffer from this is when they say, this is more flexible, or in the future, we may want to, ... So the cost of premature generalization. By the way, generalization is not bad. It's only when it's premature, arguing that it's bad. The cost is that you make your code typically harder to read because the specific task or the specific actions that your program is taking might be spread out in more places. And to read the code, you have to move around in more different places. For instance, if you're creating if you have a dynamic dispatch call, for instance, you might actually have to figure out which function is being called. You end up with less tested code because when you make something very generic, you're likely only testing a few specific cases. You're not, your tests aren't taking full advantage of all of the flexibility in the code. So either you have less tested code or you spend much more time writing tests for all the cases that you don't actually use in production. And you might also spend less time solving today's problems while trying to solve potential future problems. And another one is performance. In my personal experience, many optimizations you get by collapsing abstraction layers, or abstractions. So you see exactly what's going on, and you write a specific function for a very specific use case, and you can make it much more efficient with all of those assumptions for the specific case. So this is an old quote from attributed to John Carmack. It's been frequencing this meetup a few times, I think. It's hard for less experienced developers to appreciate how rarely architecting for future requirements applications turn out net positive. This sort of captures the essence of this. So I think thinking about this, it led me to thinking, why is it that we have this urge to generalize our code prematurely? And I think one explanation could be how we view programming. Is our job to produce text and we want to spend as little time as possible to change this text in the future. So we want to make this text general so that we can change less of it. Or is it that it's our job to understand a problem and the text is kind of a side effect of solving it, and it's constantly changing as we learn more about the problem. So this I refer to as theory building versus text manipulation. So there's this great paper from 1995 that I can highly recommend called Programming as Theory Building. In this paper, Peter Nauer is describing something that I think is intuitively understood by programmers, that when you work on a project, the source code that you produce is sort of a manifestation or an embodiment of your understanding of the problem, or the team's understanding of the problem. But without the team and the team's understanding of the problem, the source code isn't that valuable. It's very difficult to change it. And we know this partly by trying to work really hard to make it easier for someone else to read the source code and understand it. There's like all of code guidelines, recommendations for how to comment things, documentation. It's all about making it possible for someone, an outsider, to get in and understand the code. The understanding is primarily formed in the brain of the original engineers. So I think having this view helps also with how you write comments in your code. We all know that you're not supposed to write, or it's kind of meaningless to write comments describing exactly what the programming language means. So you don't say what something does. Maybe you want to say why it does it. But maybe you even want to take a step back and describe sort of the idea at a higher level. Essentially, sort of documenting the theory of the problem or the program. So it kind of comes down to this question. Is it cheaper to rewrite a function from scratch or to change it a little bit? And if you're having the text manipulation sort of point of view, then then you don't want to rewrite the function. Then you want to be able to change it because it's text. You don't want to change the text so much. You don't want to discard the text. Whereas if you're coming from the theory building point of view, then it's the idea that's important, not the text itself. So you can rewrite it and probably do a better job the second time. But obviously, it's not always one or the other. So the second time, or the first time you implement, you solve a problem, you learn about all of these bottlenecks, edge cases, what's common and what's uncommon, and what are the worst cases of your program. So this will really help you improve if you rewrite it versus trying to tweak it, right? So I think there's also an aspect to the buy versus build question. If you need a solution to a problem, do you buy something off the shelf or do you implement it yourself? I don't think that's an easy question, but I think the sort of not invented here tendencies, I think they probably come from this idea that you buy a program, then there's going to be a lot of work to then have your team understand it. And maybe sometimes it's going to be more work to understand it than to just write it yourself, but maybe not. But it's a question worth asking at least. So the punchline is to embrace rewrites. When you write your program the first time or your function the first time, expect it to be rewritten. Don't optimize it to not rewrite it. It will probably be rewritten at some point, but maybe it's good enough for years, the first version of it. But at some point, it's probably going to be rewritten. And anticipating what the next version will look like or what kind of features it will need is often futile. You won't know until you get there. That's all.